Okay, welcome back to SPSS Part 2. This is the fourth component to this, and we'll be looking at the independent samples t-test and the procedure that's involved with that. So let's look at the three types of t-tests that are available to the researcher. All of them have to do with comparing means of a group to some other information, some other group that has a mean. And so the one sample t-test, you're already familiar with that through the work that we did with the Clark and Stoner article. And in that one, you recall that we compared a group mean to some sort of standard. So we compared the mean spelling scores for Braille readers to a standard of the normative population, people that were tested with the spelling test. And so we made that comparison. The second one, which is what the focus of this particular component of the video series is the independent samples t-test. And so with the independent samples t-test, you're going to be comparing the means between two independent groups. So two groups that don't overlap, don't have anything to do with each other. We're looking at their means on some dependent variable. And then finally, the third type of t-test, which is covered in Chapter 7 of the Aki test, is the dependent samples t-test, or sometimes called the repeated measures t-test, because this is the one that you would use if you had a pre-test, post-test situation where you wanted to compare the gains and scores on a test or an instrument between two groups, let's say a control or a treatment group. So in this dependent samples t-test, we're comparing two sample means when the samples are related to one another in some way. So let's go back and look in a little bit more detail about the independent samples t-test. And this is used to determine whether the means of two groups differ significantly on some variable of interest. So looking at the two types of variables that are in this analysis, you have an independent variable that has to do with group membership. So it could be males versus females, it could be treatment versus control group, but these are categorical type variables that you would use a 0 or 1 or a 1 or 2 to designate or code for that particular group membership. The second variable is a continuous variable. The dependent variable is whatever you're interested in looking at, be it raw scores on a test or the number of times that something happened over the past. So this would be some sort of continuous scale variable that you could look and determine some sort of mean, and that you would want to compare the means of your two groups identified by the independent variable. So in looking at the hypotheses that you would set forth when doing an independent samples t-test, the null hypothesis would be that the mean for the treatment group was equal to the mean for the control group, or the mean for the first group was equal to the mean for the second group, whereas your alternative hypothesis would say that those means were not equal to one another. So recall that we would be interested in rejecting the null hypothesis in this case, and so really what we want to try to show is that the means are really different from one another. So there's several assumptions to the analysis, and the first one is that those observations are independent. So each of the people or the participants in each group, they are not connected to each other in any way, and they don't really influence each other, so they don't cross over between the two groups that you're looking at, the means for those two groups. The dependent variable is normally distributed for each group, which is the second assumption of this variable. We're going to look a little bit more in detail on this in class because it's a little bit complicated, and we'll be learning a process to determine whether the data are normally distributed or not. And so we'll be looking at some key indicators of that. The third assumption of the analysis is that the variances for the two groups are equal. Recall that variance has to do with the spread outness of the data, and so there's actually a test built into the analysis in SPSS, which will perform a Levene's test for the equality of variances. It is somewhat sensitive to the size of the sample, in that if you have a large sample, then it's likely to um, uh, lead you to reject the null hypothesis. But the two hypotheses for the Levine's test is the null is that the variances are equal. Whereas if that's rejected, then we might assume that the variances are not equal to one another. Recall that our goal here is to ensure that the variances for the two groups are indeed equal. So since we want them to be equal, we don't really want to reject that null hypothesis. So if the results of Levine's test gives you a p-value of greater than 0.05, then that's a good thing, and that indicates that the variances between the two groups are equal in the population. So that's a good thing. So that pretty much wraps up the background information about the independent samples t-test. So we will now go on to take a look at the actual analysis. So I pulled up here for you the therapy data set that's part of the Yaki example for chapter 6, and you can see that therapy is the type of therapy that's being provided, and depression is the score on some sort of depression scale. If we look at under the variable view, you can see that I have coded the values for the therapy to be either one, psychoanalytic type therapy, or two, a cognitive behavioral type therapy. So what we're trying to do is to figure out, is there a difference in the mean score on this depression scale between patients that have received either psychoanalytic treatment or a cognitive behavioral type psychological treatment for their for their depression. Okay, so in the data view here, you can see the first group here. These are the people that received the psychoanalytic therapy, and then the cognitive behavioral down here. And you can see their scores on the depression scale that was administered to each group. So in order to perform an independent samples t-test, we're going to click on Analyze, and what we want to do is compare means. And so you recall doing the means procedure earlier. One sample t-test, that would be similar to the analysis that was done for the Clark and Stoner data. So we want to pick the independent samples t-test. So when I select that, you can see what I've done is I've dropped the variable called depression as the test variable or the dependent variable. And then the therapy variable I've put in here for the grouping variable. So if we look at how I've defined the groups there, you can see I've put in a 1 and a 2 under group 1 and group 2, and then clicked on continue. And then it defines the difference between those two groups. So this is a pretty simple analysis. There's really not much else involved besides that. So I'll click on OK. And when I do that, you'll notice that there is let me just widen this up a little bit for you. You'll notice that the results of the t-test comes up. And under group statistics, it's going to give me the means for each of the two groups. So for the psychoanalytic group, I can see on this depression scale, they had an average score of 56, whereas the cognitive behavioral group received a mean of 45 on the scale. So those individuals that were higher on this depression scale were more depressed. So we can see superficially that it looks like those receiving psychoanalytic therapy had a higher mean score or more depression than those receiving cognitive behavioral interventions. And so we can see the standard deviations. And then under that, we have the data for the independent samples t-test, which is what we're mostly concerned with. And then so up here, we can see Levine's test for equality of variances. So recall that was one of our assumptions of the independent samples t-test, is that the variances between the two groups were the same or close enough so that we could perform the analysis. And you can see here that the significance of this, or the p-value, is 0.582. So we can reject the null, or we can accept the null hypothesis, or fail to reject the null hypothesis that the two means have different variances. Two groups have different variances, and so we would therefore not reject the null, which is a good thing for us because we don't want to reject that null hypothesis about the equality of the variances. Then as we move to the right, we can see there's a t-value here, which is about 3.5. And realistically, just as a rule of thumb, if the t-value is 2 or higher, usually that represents a significant difference between the two groups. The table provides our degrees of freedom. Recall from the last chapter that degrees of freedom is the sample size minus some amount. In this case, we have two groups, so it's a sample size of 30 minus two groups, which gives us 28. Then here's our p-value for the two-tailed test, and you can see that it's 0.02. So that tells us that that's way less than 0.05. So we have achieved a significant result, which means that there's a significant difference, a statistically significant difference between the depression scores of the group that was treated with psychotherapy versus those that received a cognitive behavioral type intervention. So that's the results of our t-test. Then the next steps for the researcher would be to write up those results and discuss that. And Yaki provides for you an example, as we discussed in the last video, that example of how to write that up in APA format. You would take your data for whatever analysis you happen to perform and insert that in there. And Yaki provides that for you on page 78. So I encourage you to get started on the assignment and use the information in Yaki. He does provide a very good background in addition to anything that I might have added to the conversation here. So good luck in that assignment.